tine tiller. Okay, leave it out. Spelling mistake, maybe. Spring tine tiller. Right. Toughness. A material is tough if it is capable of absorbing a great deal of energy before it fractures. So toughness means more hard, very hard toughness, like glass or something like that. Okay, you can have it. Number 8, next slide. Selection of material. So this is a very vast subject, but I have already suppressed to this around 100 slides. Today I have completed nearly 60 slides. I will show you everything. Just to understand with a small introduction of these workshop practices. Selection of material. Workshop technology. So what is workshop technology? A systematic function, operation, maintenance, and repair of farm machinery needs for better machinery management practices. So workshop technology. So actually this machinery management. What is the meaning of management? Management. So if you have more age, that means you can have management. What is machinery management? Management includes several things, right? So this is not the time for explaining management. But anyway, management has planning, organizing, leading, controlling, motivation, staffing, and coordination. So all those activities compressed as one, that is known as management. So it is a vast subject, but anyway, you little understand what is management. Management means actually you are challenging with job and make feasibility of that particular activities. Right? Management. Simply we understand. Then metal. Iron, steel, pick iron, cast iron, alloy cast iron, malleable cast iron. So here we utilize iron. Fe, that is iron. Fe is the fundamental metal. So our world is actually based on this fundamental metal. Now the scientific world, actually metal world. Then we are going to have iron and its derivatives. So we utilize this iron, Fe, by adding of carbon, by adding of different metals that can be possible in foundry, where you can have 23,000 degrees centigrade of metal liquid. Like that, okay, you understand little. Therefore, now metal world, iron, from iron, we add, with pure iron, we add a certain amount of carbon percentage, carbon particle. If you have 0.25% of carbon particle added to any metal, added to iron, that is known as steel. That is steel, making steel. Okay, that is very simple steel. Then steel level, you can go up to 1% level. Then another adding of carbon particle, you can go up to 4% level. 0.25% level carbon, 1% carbon, and then 4% carbon. All are iron. So this is the process of making steel. Steel means iron plus carbon in different percentage. Say example, cast iron may have 3 to 4% of carbon. Then steel may have around 1% carbon. Then 0.25% of carbon, that is known as rough iron. Have you heard? I don't know. That is known as rough iron, steel, cast iron. Increasing the percentage of carbon, increase the strength of the material. So that is actually, we are making different type of steel. Our main point is making steel. Rough iron, steel iron, and then cast iron. These are the three groups we have. Right, that is metal. Properties and treatment of iron. Brittleness, ductility, elasticity, hardness, malleability, plasticity, roughness, strength and appearance. There are different type of properties available in metal. So by having heat treatment, we can have different type of metal, especially steel, with different characters, different characters. You can have it, right? So only by having heat, the metal characters can be easily changed, or the property can be easily changed. So that is why we are dealing with metal with heat. Heat. So then we go to heat treatment. Heat treatment, annealing, normalizing, hardening, tempering, crunching. There are something available, right? Anyway, don't tell everything is not nice, but only limited knowledge. That is enough. Okay, you remember annealing, normalizing, hardening, and tempering. Tempering means intermittent heat application of metal. That is known as tempering, intermittent heat application. Then hardening, an expected level of heating, you can have it below than creep. There's a guideline, that is the maximum temperature you can go. So then hardening you can accept. Then normalizing means increasing the strength of steel by heating metal. Then we have another one is annealing. Annealing means we are doing heat treatment. At the same time, we can have softening of metal. That is a very important area. Softening of metal. We are doing heating, but the result is softening of metal. So then that metal can be utilized for different job, light, simple job or light job, not heavy duty, light duty. So we can have light duty material. Light duty means very simple work, right? That is the meaning. Say example, small knife, very small knife, something like that, right? Like blade, shaving blade, like that example you can have it. Anyway, you study little. Then number 9, okay, heat treatment of steel. Our basic thing is metal world, only iron, Fe. From Fe we derived different materials, steel and the steel alloys, right? Cast iron, mild iron, there are so many things are available. But mainly we think about rough iron, steel and cast iron. These are the basic thing. Rough iron is having around 0.25% of carbon. And then steel around 1% of carbon. And cast iron maximum 4% of carbon. So in the intermediate level, so we can produce different type of steel for having utilization of different type of job. So you can have it. So the different type of steel can be produced according to our requirements. One thing. The second point is, so we can have some alloys. Alloy means mixture of metal. So you can mix 2 metal, or you can mix several metal, 3 metal, 4 metal, 5 metal, something like that. That is known as metal alloy. So we have 2 different type of treatment. Heat treatment, where you utilize the percentage of carbon. The second one is, we are producing alloys for our work. So this is metal world. So we are doing that one. Hardening, normalizing, tempering. Normalizing, this heat treatment process is carried out to give the steel its normal structure. So I am not mention about the structure in future, in further. I can mention about the structure of the metal, where you have different type of structures. So you have to study how to maintain the strength and hardness of material. So we need some basic knowledge on structures. This gives faster rate of cooling than annealing, faster rate of cooling than annealing. Annealing, we utilize that one for cooling continuously. It is being taken by its own level of heat dissipation. But in normalizing, so the cooling is highly fast. Say example, thing like crunching. Crunching is, that blacksmith may have some knife. They can heat the knife. After that, it can be inserted into the water or sandy soil or something like that. So we are making faster rate of cooling. The rate of cooling is fast. The rate of cooling is slow. So you get annealing. The rate of cooling is very high. That is normalizing. The third one, hardening. In contrast to annealing, this heat treatment process is designed to produce a steel that is hard. To produce a steel that is hard. That is hardening. Steel will vary in hardness depending upon the carbon content. 0.5 to 3%, 0.25 to 3%. Some typing mistake. 0.25 to 3%. So you can have it 0.25 to 4% level. So we can cover all type of steel within that. Rough iron, cast iron, alloy cast iron, everything can be included within the steel, the title of steel. Then tempering, the heat treatment process is carried out After a steel has been hardened, tempering removes some of the hardness. So that is the idea is intermittent heating or reheating based on our requirement, making the steel less brittle and more tough. So we can make it. There are two different line is available for making different type of metal alloy and metals with different hardness. And hardened steel to a temperature between 200 degree to 450 degree. That is heat treating, reheating. So very low temperature, 200 to 450 is very, very low temperature. But for hardening, we need more than 1000 degrees centigrade for hardening. So reheating, that is around 200 to 450 degrees centigrade, comparatively less heat. That is tempering, intermittent heating or reheating. So you can have it. Right. Annealing, normalizing, hardening, and tempering. And then we go to the next slide. Heat treatment of metal. Heat treatment of metal. Tempering. Tempering, you understand what is the meaning of tempering. Intermittent heating or reheating based on our requirements. So we have a certain requirements in respect with hardness, toughness, brittleness, ductility, those are the things, right? So tempering. Then hardening and annealing. Annealing means we are actually softening metal. Softening, this is a method of softening metal. And hardening is a strengthening of metal. So different level. The flame hardening. Flame hardening, that is actually practiced under blacksmith. And then normalizing. Normalizing is actually we do heat treatment, but heat treatment we don't worry about the time factor, but the cooling section. So heating and cooling, two activities. First one is heating, then cooling. The rate of cooling is very high by adding some water or sand, soil like that. Normalizing. Rate of cooling is very high. So this is one of the methods of making hardness of metal. Then at the same time, annealing, you have softening of metal. Softening of metal, we utilize nitriding and cyaniding. So certain chemicals we utilize, and with controlled temperature, this heat treatment is being done. Therefore, types, process, and application. Based on that, we are preparing different type of steel material. This is steel world, metal world. Therefore, we are preparing different type of material. Sometimes acoustical property. So we may have that is known as creeping. That type of material is being utilized for sound system. Sound system in computer or radio. For sound system, that type of steel material is being utilized. So we are identifying new materials for specific work. Clear? Okay, we go little by little. Then number 11, okay, annealing of metal. What is annealing? Annealing means softening of metal. Why you need softening? easy for handling for any job. Easy for handling. That is the fundamental things. Softening of metal, annealing of metal. So you can have especially this figure. So soft annealing. So the original steel, high strength microstructure. This is the microstructure of steel. That is microstructure. MICRO, microstructure, some molecular level analysis. Deformable and easily machinable microstructure. Easily machinable. Machinable means that can be utilized in machines for making some other product. That is the meaning of machinable. Easily machinable microstructure. So this is slightly soft material. This is slightly hard material. Annealing. Annealing is certain temperature level. We change the internal structure of steel. So actually we are softening the metal for our further work. Right? That is known as annealing. That is enough for you. Right. Go ahead. Normalizing a metal. Normalizing. Say example, one hard person. So by having some advisors, you can have nice person. Then after that, he may turn his character as hard person. That is obvious, no? Hard person. Then by studying, you may be a soft person. And then automatically you may have hard person, something like that. Difficult man, finally. Like that, normalizing, the normal condition of the molecular structure is fairly high strength. Then we do hardening, normalizing, tempering, annealing and everything. In normalizing, the rate of cooling is very high. Oh, suddenly we cool that metal. So the metal can easily return to the original level, original position. But at the same time, it may have homogeneous microstructure. So earlier one, heterogeneous microstructure, that is earlier we have the steel. That's a hard steel, very difficult to handle. So then we change into homogeneous microstructure of metal. This operation is known as normalizing. Normalizing. So the main point is the rate of cooling is very high. That means we can have example, hot steel is inserted into water. That is the meaning. Crunching, that is known as something like crunching. Normalizing of metal. Normalizing of metal. And then you go next one. Elongation and carbon content percentage. By increasing carbon level, we are increasing strength of metal. By increasing heat, we are increasing strength of metal. That is normally visible. But unfortunately, if you go through that real things, annealing, we are softening metal by heating. Normalizing or softening metal by heating. But in final stage, normalizing, we do quick crunching. Then you get a very high hardened product. So that is why I want to introduce this graph here. Then you increase the carbon percentage. So you have more graph with high strength with low elongation, very high hardened. Say example, cast iron. You know, the engine block, cast iron. So elongation is comparatively zero. Elongation is comparatively zero. That expansion is zero, nearly zero. That is cast iron. Cast iron is being utilized in engine block. You know, engine block, engine head, oil sum, the basic structure of engine. The top you get engine head, the middle engine block, and the beneath part of the engine is known as oil sump, where oil is stored. Something like that. You can have engine, you can study further and further. So we are dealing with metal. Tempering of metal. Tempering is a very, very ideal method of heat treatment. That is actually intermittent heat treatment. Low level of or low temperature level that is being handled. And we have different type of products. The result is different type of products. So I read this passage, you see. We treat metals in an attempt to optimize the mechanical and physical properties. Mechanical properties and physical properties for a given application. Most people think of heat treatment as a process for hardening metal. This is not necessarily so. This is not so accepted. The heat treatment, based on heat treatment, the result of the metal may have different properties or character. You can have it, different characters. Only we do heat treatment. Finally, we get different characters. We utilize only steel, and finally we get different characters. We utilize steel with a certain level of carbon, so then we can have different results. So there are so many activities are involved. Carbon level, temperature level, these are the basic two things, and different combinations. There are different 100 and 200 types of different combination that can we have. So then we can produce different type of metal. That is a thing under this tempering metal, right? This is not necessarily so, as many heat treatments are applied to soften metal in order to allow metal working operations such as deep brewing, cold forging, and machining. Right? Machining, making gear wheels, forging, applying some heat and force, that is known as forging. Normally blacksmith can have anvil. There's a big metal there that is known as base, anvil. Technical word is anvil, on which you can utilize metal for making different shapes, right? Then where increased strength and wear resistance is required, hardening and tempering treatments are given. Extremely hard steels find application in cutting tools where highly defined edges must be maintained, and heat treatment of these steels is a critical operation. hard surfaces with ductile base material may be developed by heat treatment. So everything is possible that you can have it. Right? Next one. Temperature. So now third factor is timing factor. First one is temperature. First one is carbon level. Second one is temperature. And third point, time. So time factor. There are several combinations. Time and temperature. Temperature, low temperature with a different time. Right? 10 minutes, 15 minutes, or half an hour, 1 hour, right? 2 hours, something like that. Then temperature, say temperature is 500 degrees centigrade, then time factor of 2 minutes, 5 minutes, 10 minutes, 15 minutes, and half an hour, something like that. Okay. Then tempering, you can have it. The temperature may be varied, fluctuate like that. Right? Hardening, strengthening, tempering. ESK line, that is a guideline. Some name from somebody, don't worry. That is a guideline. You think about guideline. There's a guideline up to that particular point. You can increase temperature to a particular metal. That is extremely essential because increasing temperature may create different trouble, right? Troubleshooting. Therefore, so we maintain temperature level, carbon percentage level, temperature level, then time factor. Third one is time factor. Making different type of metals. The third factor is time factor. Time factor with combination of temperature, combination with carbon. There are so many combinations you can have it. Carbon level, temperature level, and time factor. Right? Austenitizing. So that is the level, maximum level. So you can have a even application of temperature. That is austenitize. Then quenching, Quenching. Quenching means sudden change of temperature. Quenching. So increasing temperature, then austenitizing, so making a certain level of temperature, right, for a certain time, and then sudden cooling, that is quenching, and then you can have strengthening, hardening, and temperature. Finally, you get different type of product with different properties. That is the meaning. We have same things. Finally, we have different type of properties. So that properties of metals can be selected for various jobs. So transmission, authentication, right, electricity level, or any work you can utilize. Identification of new metals. Hardening of metals. Hardening is the process of heating the steel to temperature sufficient to produce an austenite condition, not essentially austenitizing, depending on the carbon content of steel, followed by rapid cooling at a rate fast enough to prevent the transformation to any product phases differ than martensite. martensite. This cooling type is called quenching. Martensite. This process is known as quenching. So here austenite and then martenite. Okay, like that we can have it. The next one, purpose of hardening. What is the purpose of hardening? The main objective of steel hardening process are inducing high hardness and achieving high wear resistance for steels. Hardening is done to all heavy-duty carbon steel, So carbon steel, say example, you have 3% of carbon steel, that is extremely very hard cast iron, like that. And almost all machine parts made of all steel type. Machine parts are available, so all parts can be produced by utilization of steel. But we have different type of steels, so different type of products. Okay, clear. Then come to the next point, alloys. Now we are dealing with the metals and then alloy. Alloy means mixture of metal. Non-ferrous metal and alloys, preparation of metal. Okay, non-ferrous metal. So we have ferrous metal, that is iron. The iron can be utilized with another metal, that is steel alloy. But here we consider non-ferrous metal, aluminum, copper, tin, something like that, right? That is non-ferrous metal. Bronze, zinc and copper, zinc, brass and copper, is and tin alloy. So that alloy, steel alloy, can be utilized for hot rolling, cold rolling, molding, casting, any type of things. So this is metal world, steel world, metal world. So hot rolling can be done. Hot rolling means by heating you can have any deformation of metals. That is hot rolling. So different formation, cold rolling without utilization of heat. Molding means a mold can be utilized for baking dolls or something like that, right? Then casting, cast iron, casting. These are the things you have to study. Now the time is more or less come to the level. Cast iron, grey cast iron, metallic cast iron, and spheroidal graphite cast iron. So I have 65 slides here. I have another 4 minutes to end of this lecture. So what I want to do is, I want to show you all slides now. Altogether around 65 slides. I will run quickly, you just to have some idea. So today is the introduction lectures for our workshop practices. Therefore, so just I want to go through this, right? Cast iron, right? Cast iron, rough iron, cast iron, rough iron. Okay, very old models. Okay, rough iron we utilize for our gate. This is our gate. Okay, so rough iron. So this cast irons we utilize for pipelines and steel product we can utilize. Okay, then the next one, And these are rough iron, cast iron, and steel. What are the difference between these things? Okay, go ahead. Copper and its alloy. Copper is one of the famous metal word. Copper, aluminium, and steel. These are the very famous one, right? Therefore, so we emphasize on that copper alloys. Copper. Then aluminium alloy, you can find this is centrifugal pump, right? Then alloy properties, aluminium alloys, magnesium alloy, and zinc alloy. These are the important alloys I mentioned here. You study later, right? Metal processing, heat process, forging, riveting, soldering, bracing, punching, and everything. And then metal heat process. This is known as anvil. Anvil, the down. You hammer, anvil, and metal we utilize for malleable hot iron. This is hot work. You are screen sharing. Stop. Okay, sorry, I go this one. Okay, right. Bracing, iron, drilling, adhesive bonding, gas welding, arc welding, as welding, and the difference between these two type of welding, soldering, bracing, welding. Then main tools. These are file tools, workbench, tools, especially this file, special attention taken, safety farm machinery, then safety precaution, accident prevention, metal cutting. This is known as machining. Oh, milling. Okay. Then checking and measurements. Then the bench and flat surfaces. How to do this one. And 52, 53, marking out. 54, introduction, lathe machine. Lathe operation, that is also comes under your syllabus. Chuck work and everything. Metal joint, we have to think about the mechanical fasteners, standardization of fasteners, soldering, bronzing, welding, adhesive bonding, right, final. Merit of joining metals, then finish. Thank you very much. Hello, how are you? Now the time is 1 o'clock. I am going to stop here. Thank you very much.